Okay. Hello, everyone. Welcome to TDX. Quick show of hands. Who's already using Data 360? Oh, great. And how many of you have explored things like semantic search, vector search? Oh, okay, cool. So, long story short, enterprises are producing a lot of unstructured data. I'm particularly talking about long-form content here, PDF reports, meeting recordings, and so on. In this session, I'm going to show you how to build a business automation around these documents. So the moment new documents are produced and available in your storage, we are going to kick off a pipeline that processes the contents of it, extracts all relevant pieces of information, and it triggers your downstream workflow. Please base all your purchasing decisions based on products and services that are currently available. We know that there are a lot of incredible sessions happening here at TDX, and I truly appreciate you choosing to spend your time here, so thank you. Now, to introduce myself, I'm Sai. I'm a lead engineer here at Salesforce. I've been with the company for a little over 2 years now. My primary focus is leading the development efforts of data actions in Data 360. So, to help you get the best out of this session, I've broken down this topic into 5 sections. First, we're going to look at some challenges in real estate, particularly when a team is drowning in a lot of manual paperwork because they have to go through a huge pile of documents. Then we're going to identify some gaps that prevent us from addressing these challenges already. Then comes the vision. This is where we are going to define how your ideal systems are supposed to look like. Then comes workflow integration. This is the high-level solution architecture. And finally, the demo. How many Salesforce developers here or architects? Okay, cool. So meet Priya. Priya is a Salesforce developer like most of you. She works at a company called Horizon Properties. They're a real estate management firm. They manage tens of thousands of homes in every region. And one of the primary responsibilities is ensuring safety, right? So they do a lot of these house inspections. So they go to your home, they look for cracks on your walls, they look for presence of mold, or they look for presence of certain harmful materials like asbestos. In any of these cases, they prepare a very detailed report, and then they send their team in who could provide a potential resolution. Now, Monday morning, Priya's team has walked into a nightmare. Just over the last weekend, there were about 250 new house inspection PDFs that have landed into their system. Now, these aren't just simple one-pages. So I'm talking about reports which are at least 30 pages long. And there's a lot of information in these reports. So there's basic information like property address, inspector details, and so on, and all the way to key technical details, right, like structural findings, safety flags, repair estimates, and so on. Now, this is the current process that Priya's team follows. They have to manually read every page of the document to understand what's in it, extract what's important to them, and format it into a case record. Now, because the number of documents are really huge and the contents of it are also huge, her team takes at least 2 weeks to cover 1 weekend's worth of documents. Now, this is a huge productivity concern, right? Now, here's something dangerous that has happened. Last quarter, there was a report with a critical foundation crack, and that report was not addressed for 11 days. So, for 11 days, a family was living under a roof with structural risk, and the system was completely blind to it. This is a huge safety concern, right? Like, you do not want this to happen to your business. Now, this is where Priya sees an opportunity, and she wants to be more efficient in her delivery. So, Priya is a Salesforce developer, so why can't she solve this already? Why is this such a hard problem, right? There are 2 major roadblocks here. One is storage versus activation. If all you're doing is storing your files in storage, then you're basically waiting for some human to look at the documents and categorize. So there are 2 issues with this approach. One, if the volume of the documents is so huge, it obviously takes a lot of time for your team to go through them. And 2, even if they were to somehow go through all of the documents, it's very much possible that they could miss out on certain pieces of information because they could have overlooked it, right? So the next gap is keywords versus intent. If your legacy systems are hunting for keywords such as strings or regex patterns, then your system is going to fail. So let's take an example. Say you have a report, and the inspector has mentioned something as structural compromise. But your legacy code, it is looking for keywords such as broken. It is not going to find it. You as a human, you can understand that both of these terms could mean the same thing, but your systems cannot. So, after the 11-day incident, Priya has finally decided to define a new vision for her team, and these are her goals. So first is automated case creation. So the moment new PDFs land into the system, she wants to build a system that goes ahead and creates a case record. And not just that, she wants the case record to have been created with the right type, right priority, and the right queue, everything automatically. Then comes immediate action. She doesn't want her team to manually search for any information, like scrolling through dozens of pages. She wants her system to have pre-extracted all the necessary information before the report ever hits a human's desk. Then comes VectorDB integration. Priya wants some sort of semantic brain. She wants to gain some insights on her unstructured data. The same example that we have taken before, right? Like 2 keywords could mean the same thing. That's where VectorDB can kind of help you here. So if you search for broken, you could probably get back results that could say structural compromise. Then comes AI reasoning. She wants to use LLMs to categorize these reports with high confidence. Now, Priya is a Salesforce developer, and she realizes that Salesforce is actually her unfair advantage. The reason being there are 3 different systems working as one. First is a CRM platform. This is a system of record. This is where there's support for case records, there's support for knowledge articles, everything's already there. She does not need to go anywhere outside. And she could orchestrate all the business logic right from within the platform. Then comes Data 360. This is the semantic brain. This is where your VectorDB lives. And Data 360 already seamlessly communicates with the CRM platform. You do not need any complex setup or integration here. Then comes Einstein. All the ML predictions and LLM reasoning, everything's available there. So if for some reason, if you attempt to parse your documents within the CRM platform without Data 360, these are some of the limitations that you could run into. I mean, for instance, in production, you could be dealing with documents that are hundreds of pages long or even thousands of pages long. So the size of them could easily exceed a few MB in size, right? So your Apex heap size limit is about 6 MB. So if your documents exceed more than that, then that's going to be a problem. And say you're dealing with large unstructured data sets, right? Or maybe even videos, which are at least hundreds of MBs in size. Your AI inferences could take in the order of, the processing time could be in the order of minutes. Now again, that's not something that is already supported in the CRM platform. So Priya wants to kind of process her documents outside of the CRM platform. So she wants a way to process her documents outside of the CRM platform, but still be able to use those findings in the CRM platform. So that's where Data 360 comes into picture. So let's look at the workflow integration. This is the high-level solution architecture. You could have your documents in any of your storage providers, right? It could be S3, GCP, Azure, or even SF Drive for that matter. So you could bring your documents into Data 360, and they end up in something called UDLO. Again, if you're new to Data 360, don't worry about these terms. Know that UDLO stands for Unstructured Data Lake Object. Think of it as a table with records and fields. At this point in time, please note that we do not copy the contents of your document. We only store file references in the UDLO. And then we create something called UDMO and map it to UDLO. This is a one-to-one mapping. Know that UDMO is more like a view on top of your data. So then we create something called search index. It's a process definition. So you create it on the UDMO that you've just created. Search index results in 2 new tables. It's called chunk table, and then there's an index table. So your incoming documents, every document is basically broken down into smaller chunks. So say you have 100 pages in your document, and each page has about a few paragraphs or a few sections. Each paragraph or section could be a chunk. Again, it depends on the configuration strategy. Like I'll show you in a bit how. But that's how it is, right? Like your entire document is basically broken down into smaller chunks, and each of your chunk record has a corresponding record in the index table. So your record in the index table has vector embedding generated over there. Again, same example as before. Vector embedding think of vector embedding as a numerical representation of your chunk content. Again, if you search for similar keywords, it will help you with better search results. Then we create something called vector search data actions on your search index. So here's what's going to happen, right? Data actions is going to fire something called a platform event. In this case, it's a data object data change event. It is going to fire one event per every document that is coming in. And not just that, right? If your document is hundreds of pages long or even thousands of pages long, your team need not be interested in every part of the document. They could only be looking at certain sections of the document. So that's where vector search data actions helps you. It accepts something called a search query, or you could think of it as an intent that you're looking for. So we look at all the pages in the document, or basically all the chunks in the document, and figure out which of the chunks have information that you're looking for. And we pack them in the same event, and we send it to the core platform. And then we create something called, and then we have an Apex trigger on the core platform side. This consumes your platform event. Your Apex class extracts your event payload. It has your vector search results. It has some information about your document. And it constructs a well-defined prompt, and it sends it to an LLM. It gets back some response. And the same response is used to create a case record. Now, let's see it in action. So, again, same use case. I have two reports here with me. Both of them are house inspection reports. In these inspections, we look for presence of certain harmful materials in your house called asbestos. So these materials are harmful because if you inhale them, they're very dangerous to your health. So I have two reports here with me. They're both in French. Don't worry about the language for now. Just know that the first report is asbestos positive and the second report is not. So the first report is where the homeowner needs further help. So we have a huge report here with us. So there's about 30 pages in here. Notice how the first report is very detailed, that it has mentions of which areas or rooms are actually affected. Right? So you see all of these red markings that tell you that tells you which areas or rooms are affected. But again, the second report does not have any such information. All it has is a simple summary that tells you that, hey, there's no asbestos found in the house, you're all good. So these two documents are sent through the pipeline that we just spoke about in the previous slide. And we are expecting a case record to have been created just for the first report and not for the second one. Because your second report is all fine. You don't need to worry much about it, right? So here's a sample case record that was created after sending the two documents through the pipeline. You see how everything is neatly extracted out and put into the description field here. So we have some basic information like property address, inspector details, and so on. And there's details about which rooms or areas are inspected, what is the summary of the findings, and some potential recommendations too. So this is all auto-generated. Now let's see how this was made possible. So for the sake of demo, I have uploaded both of my documents to Agentforce data library. So here is where both of my documents are available. And here's the UDLO that is created on top of the library that you've just seen. And this is the UDMO. This is a one-to-one mapping. Again, as you can see, we do not store the file contents here. All we store is file references. And here's the search index that is created. As you can see, there are two new tables that are created, which is one is the chunk table and one is the index table. And here's the configuration for it. So there are 3 steps in search index. One is parsing, second is chunking, and third is vectorization. For chunking, we are relying on GPT-4o. And for parsing, we are relying on GPT-4o. For chunking, there are a bunch of different strategies that you could configure based on the file extension. In our case, what we're interested in is our PDF documents, right? So we have configured something called section-aware chunking. What it means is, say your page has multiple sections. Each of the section could be a chunk. And then there's vectorization. Here is where your chunks are converted into vector embeddings. As you can see, we have picked multilingual E5 large embedding model. If you've just seen in the previous PDF document, the reports are in a different language, right? So that's why we have picked a multilingual model here. Now, let's also query some of these tables to see how the data looks like. So here's the UDMO. We're expecting 2 records here because we have 2 documents at this point. So as you can see, here's the file path, because all we're storing our file references. Now, let's also query the chunk table. So the search index has basically broken down the first report into 49 chunks. And if you look at some of the fields here, there's a chunk field. So the actual chunk content goes into this field. And here's the index table, or you could call it vector embedding table. So there's a, for each record in the chunk table, there's going to be a record in the vector embedding table or the index table. And here's the vector embedding column. As you can see, these are all just numbers, right? Like this is a mathematical representation of your chunk content. And finally, we go ahead and create something called data actions. Again, so the target is a CRM platform here. And then you configure additionally something called search parameters. Here is where you give your search context. This is basically your intent in terms of what information that you're looking for in your documents. So what we're looking for are areas or rooms which are affected. I want to be able to directly get to these sections or pages rather than having to scroll through all the information or all the pages, right? So here's the search context that's given. This is a dense search query. And then there's something called result limit and score threshold. So your intent is basically matched with each and every chunk. And the most matching chunks are provided to you in your event payload. So what 0.7 here means is that there's going to be a similarity score that's computed against each chunk. And unless your score is above 0.7, we are not going to pack that into your event payload. And the maximum number of results are limited to not more than 10. So here's how the event payload is going to look like. There's something called relevant results field that is going to contain your vector search results. So here's a sample payload. So at the top level, we have all the fields from your UDMO. And again, as we have seen just in the previous slide, that there's a relevant results field. So here is where all of your chunk contents are returned. As you can see, here's the actual chunk content, and then there's a score field as well, which will tell you how similar this chunk content is to your intent. The values of the supported values are anything between 0 and 1, 1 being a perfect match. And on the Apex side, we have an Apex trigger that consumes this platform event. So your Apex class is going to extract the event payload. Again, what we're interested in at this point is something called, relevant results, which are vector search results. So we're going to extract that. We are going to combine all of it, all the chunks into a single variable. And finally, we are going to construct a well-defined prompt and send it to an LLM. If you look at this prompt, we are expecting a JSON response back. And if you look more closely, there's something called, there's a Boolean field where we're expecting whether there are any harmful materials found in the house or not. So if your report says, if LLM says yes or no, based on that, accordingly, we go ahead and create a case. And finally, we build the case with all the fields that are returned from the LLM response. So yeah, that's pretty much it. Thank you. Thanks for taking time. So feedback is a gift. So please share your feedback so we can continuously improve. You can learn more about what we just spoke from this code here. Thank you.